this is partial fraction decomposition video explanation. Before we go to the concept itself, let me introduce you the thought of why we should do partial fraction decomposition. So for example, I have this a sum of rational algebraic expressions like this one, okay? And let's just do the sum. Of course, we know that before we do the addition, we need to make the denominators the same. So I will multiply on the left fraction, sorry, with the orientations of the line. Okay, so let me just, okay, this is a little bit off. And x minus 2 times x plus 3. Added by, so the right fraction, I will multiply it by x minus 2. So we will have, let me just put the same in order like this, right? So if I simplify this, it will be 3x plus 9, okay, okay, and let me just go directly, okay, just to save the time. So this one will be x minus 2 times x plus 3, and in the end equals, it will be 8x minus 1 over, let me just simplify the denominator, it is x squared plus x, sorry, minus 6. Done. Okay, now partial fraction decomposition means if I give you these rational algebraic expressions, 8x minus 1 over x squared plus x minus 6, can I separate it into an additions of two fractions, which the first fraction has the first factor of the denominator and the second fraction has the second factor of the denominator. It means like if I have this as an expression, is a quadratic one, if I find the factor, it will be x minus 2, it will be x plus 3. So I want to do the partial fraction decomposition, so I can separate this one fraction into two fractions with the denominator x minus 2 at the first and x plus 3 as the second. Or I can change the order. It can be, or I can be, this can be x plus 3 plus x minus 2. Anyway, so I need to figure out what is the numerators. So in the end, you're supposed to know that the answer will be 3 and 5. 3 will belong to x minus 2. 5 will belong to x plus 3. And also, if we put this in this order, it means this is 5, this is 3. Okay, so that is the objective. So we do the reverse. So when I give you the rational expressions, you figure out the addends. What are the addends? Okay, so let's do that. Because of course I have prepared you the same. So this is actually the same. Look. So actually the answer must be this one. It must be this one. But let us just pretend we don't know. Let us just pretend that we don't know that it will be 3 over x minus 2 plus 5 over x plus 3. So let's just do this one, partial fraction decomposition. So the first thing that you have to do, since I know this is a quadratic, it means maximal, it has two factors, maximum. It can be, of course, it can be not, it can be unfactorable, of course, but for this one, maximum, it will be two factors. Let's just factor it. So I know with the conventional factor method, it is x plus 3 and x minus 2. We have two factors. It means I can separate this into two fractions, which is the first fraction, it will be x plus 3, and then the second fractions will have the denominator x minus 2. Okay, so let's just assume it is addition. Okay, this is just an assumption, okay, because we don't know. And then let's put a here because we don't know what is the numerator for x plus 3, and b here because we don't know the numerator of x minus 2. So the objective is we want to find what is a, what is b. Okay, so let me just erase this one. Now, how to find a and b? So the trick part is, let me just write it this way to make it easier for you to see. So 8x minus 1 over, okay, I cannot do well with the line here, over. Now I will factor the denominator like this. So it will be equal to x a over x plus 3 plus b over x minus 2, right? I'm just changing this one. Okay, so if I see this, okay, and I multiply it all, so I will just multiply it all by x plus 3 times x minus 2. Okay, if I multiply all, can you imagine? So the result will be 8x minus 1 equals a multiplied by x minus 2 plus b multiplied by x plus 3. Okay, so let me just show you if you don't have the idea why. So if I multiply it by this, so this one I will multiply it by x plus 3, x minus 2, so I can cancel this. That's why it's only a times x minus 2, right? At the same time, if I multiply this by x plus 3 and x minus 2, and then I cancel this one, so the one that being left is b times x plus 3 because I cancel it. So yeah, let me just make it clear. So let's just continue now. After we have this, what are we going to do? Since our objective is finding the a and finding the b, right? So I will use the zeros, okay? The zeros of the factors, this one and this one. So if x equals, what is the first zero? Negative 3. My equation will be 8 times negative 3 minus 1 equals a times negative 3 minus 2 plus b times negative 3 plus 3. Okay, see, look at the why we use the 0. So it is negative 24 minus 1 equals a times negative 5 plus b times 0. So that's the objective. We want to make one of the addends become 0. Therefore, I have negative 25 equals negative 5 times a. Therefore, a equals negative 25 divided by negative 5, it is 5. So I find a. So a, let me just erase that. Therefore, a is 5. Wait, where is it? Okay, so now let me change, let me use other x, other 0 to find the b. If x equals, now the second 0 from the second factor is 2, right? If x equals 0, then 8 times 2 minus 1 equals a times 2 minus 2 plus b times 2 plus 3. So in the end, I have 16 minus 1 equals a times 0 plus b times 5. So b equals 3. Therefore, I know that the b equals 3, so this one actually 3. So let's just compare. So this is the answer. This is the answer of our partial decomposition. Let me compare with the before. Yeah, so it is 5 over x plus 3 added by 3 over x minus 2. So it's exactly the same. I just changed the order, commutative, commutativity axioms, right? So for addition, so it's fine. So yeah, that's how you do the partial fraction decompositions. But I will give you one more example about. Now let's do this one. Okay, this is a rational expressions, and we need to do the partial fraction decomposition. So first, because this is a cubic, okay, this is a cubic. I know that maximum there will be 3 factors, right? So let's just factor it. How we factors like higher degree of polynomials? One of the method is using factor theorem. So, but this one I don't want to show you how to use it. Let's use the factor theorem by yourself. Try it yourself. And in the end, I know that the first factor is x plus 2, and then the second factor is x plus 3, and the last factor is 2x minus 1. Okay, with okay, let's just pretend that we have already known the factors. Therefore, since I know that the factors of the denominator, okay, let me just emphasize it is the denominator, so I can separate this into 3 fractions. Okay, let's assume all has additions because I don't like subtraction, so let me just put it this way. Okay, then. So the thing is, I don't know what is the numerators of each fraction. So let's just put A, B, and C, for example. Okay, now the objective is we need to find what is the numerators. Okay, because we have already found the factors of the denominator. So what the thing that you keep in mind that we are not dealing with the factors of the numerator if there is. Okay, we don't bother to factor this one. Okay, just leave it be because it doesn't really necessary. It isn't really necessary, sorry. And so how do we do the partial fraction decomposition? Of course, let me just show you in other form. So I will try to convert this one into the factors. So the factors is x plus 2, x plus 3, and 2x minus 1, right? So we want to do the partial decomposition. So we separate it into 3 fractions, and each fraction has the one factor on the denominator. Okay, so to find it, the easiest way is I want to multiply all by x plus 2, x plus 3, 2x minus 1. We don't like fractions, right? So the objective is we want to get rid of the fractions. So we multiply all by all of these three factors. Therefore, since all of on the left member, all of the denominators will be cancelled. So it will be 9x squared plus 11x minus 34 equals a multiplied by x plus 3 multiplied by 2x minus 1 plus b multiplied by x plus 2 multiplied by 2x minus 1 plus c multiplied by x plus 2 multiplied by x plus 3. Why? The reason is the same with the before. Since if I multiply all by these 3 factors, one of the factor will cancel one of the denominator, right? And the one that being left is just the other factors that not being cancelled. Okay, so let me just continue. After this, what? Of course, let's just substitute each of the fraction. Sorry, each of the let's just substitute x with the zeros. So we have 3 zeros, right? Let me just put in other. From the first factor, the zeros is -2. From the second factor, the zeros is -3. From the last factors, the zeros is half, right? So let me just put, if x equals -2, the first zeros, so the whole thing, this one, will be 9 multiplied by -2 squared plus 11 multiplied by -2 minus 34 equals, let me just -2 plus 3 multiplied by 2, -2 minus 1. Okay, it's kind of complicated. Plus, but of course, I know that if I put -2 here, it will be 0, right? So b multiplied by 0, right, multiplied by 2, -2, -5. So plus, let me just calculate it directly. It will be c multiplied by 0 multiplied by 1. Okay, therefore, b multiplied by 0 multiplied by -5, it will be 0. C multiplied by 0 multiplied by 1, it will be 0. So the what that being left, the last one that being left is 9 times 4, which is 36, minus 22, minus 34, equals a times 1 times -5. Okay, so in the end, we know that -20 equals -5a. Therefore, a will be equal to -20 divided by -5, 4. So we have found the first piece of our puzzle, which is a. This one is 4. Okay, so let me just erase it. So for the sake of the space, let me just erase this one. If I use the second zero, if x equals -3, therefore my equation will be 9 times -3 squared plus 11 times -3 minus 34 equals, this one will be 0, right? So it will be a times 0 times -6, -7, okay, plus b times, this one, it will be -3 plus 2. This one won't be 0. 2 times -3 minus 1, okay, plus c times -1 times 0. If I put -3 here. Therefore, this one will be gone. A times 0 times negative 7 is 0. C times negative 1 times 0 will be 0. So the one that being left is 9 times 9, which is 81, minus 33 minus 34 equals B times negative 1 times negative 7. So it will be 14 equals B times 7. Therefore, B will be equal to 2. So we have the second piece of our puzzle, the B equals 2. Remember, do not change the order, that 2 cannot be the numerator for 2x minus 1, 2 cannot be the numerator of x plus 2, it has to be the numerator of x plus 3. Okay, we cannot put it random. So yeah, so the last piece is C. So let's do that. Use if x equals, the last 0 will be half. Okay, therefore our equation will be 9 times half square plus 11 times half minus 34 equals, okay, this one will be a multiplied by 3 half multiplied by 0, right, plus b multiplied by 2 half multiplied by 0, plus the last one is c multiplied by 2 half multiplied by 3 half. So the last piece of puzzle will be fractions. Yeah, it's challenging, of course. 9 over 4 plus 11 over 2, but it's still doable. So this one is gone. This one is gone. So the last one will be c multiplied by 5 over 2 multiplied by 7 over 2. 36 over 4. Okay. So, and then it will be equal to c multiplied by 35 over 4. Okay, so I need some space here, so let me go to this one. Okay, where's it gone? So after I simplify the left member, it will be like negative 105 over 4 equals c multiplied by 35 over 4. Therefore, c equals negative 105 over 4 multiplied by 4 over 35. So it can be cancelled. In the end, it is negative 105 divided by 35, which is negative 3. So our last puzzle, or C, is negative 3. So the conclusion is, when I do the partial fraction decomposition and I try to divide, let me just say divide, I just find the 3 addends of these rational expressions. This one, it will be 4 over x plus 2 added by 2 over x plus 3 minus 3 over 2x minus 1. So you can do it that way. And that is the final statement. Okay, so yeah, that is partial fraction decomposition. Hopefully this video can help you to understand. Thank you for listening.